Hello, Mike here. In this video, I'm going to explain how to choose the right heating curve when operating a combination boiler equipped with smart thermostats and weather compensation sensors. Before I do that though, I thought I would tell you how a standard combination boiler works. It operates without the advanced features of smart thermostats or weather compensation. The thermostat is usually on a wall somewhere in a hallway where it picks up the room temperature. It has a basic dial or button for turning up or down the heat, or one might be able to even set a daily or weekly timer. The combination boiler typically provides hot water and heating, but lacks the ability to adapt to changing weather conditions, which means they can only operate at a fixed flow temperature of between 70 and 80 degrees. This is the temperature of the water that's sent to your radiators to heat your home. This is very hot water, which can lead to higher energy consumption, especially during milder weather where less heating is required. Typically, your radiators get very hot and require adjustment via the TRVs. A Vaillant ecoTEC Plus boiler with sensor comfort and weather compensation is designed to maximize efficiency by dynamically adjusting the flow temperature based on both the outdoor temperature and the indoor temperature. This means there isn't one set flow temperature. Here's how it works. Weather compensation. The outdoor sensor tells the sensor comfort control how cold it is outside. The colder it is, the higher the initial flow temperature will be to compensate. It does all this using a heating curve, and I'll show you that shortly. There's also load compensation. The sensor comfort control also monitors the indoor temperature. As the room temperature approaches your desired temperature, the control gradually reduces the flow temperature to avoid overheating. This allows the boiler to operate in condensing mode more often, maximizing efficiency. It does all this through the room temperature mod, which is a setting in the sensor comfort, and I'll show you that shortly. All the parts are crucial in optimizing heating efficiency, ensuring comfort, reducing energy consumption, and ultimately helping to lower your energy bills. So what is a heating curve? A heating curve is a graphical representation that illustrates the relationship between the outdoor temperature and the flow temperature required for the heating system. In essence, it helps determine how hot the water needs to be in the radiators or underfloor heating system based on the current outdoor temperature. The goal is to maintain a comfortable indoor temperature while minimizing energy usage. So what components are used? Well, there's of course the boiler. It has a gateway that talks to the smart thermostat. And of course, there's the outdoor sensor, which typically sits on a north-facing wall and communicates the outdoor temperature to the smart thermostat. The smart thermostat also contains the heating curves, and I'm going to get to that shortly. The smart thermostat also has daily schedules and weekly plans, and it's smart in that it learns our preferences to heat in the home. So let me talk about the heat curve and how it works. So you've got the outdoor temperature that runs along the bottom of the chart or graph, which is the x-axis. It starts at 20 and it goes to -20, and then there's different temperature ranges in between. Along the y-axis is the flow temperature. And remember I said a standard combination boiler's flow temperature is between 70 and 80 degrees. So bear that in mind. So the way this works is in the sensor comfort, there is a menu option to set the heat curve. And there are a number of heat curves. They start at 0.1 and they go all the way up to 4. So I can show you through the app. I can go to Controls, Heating Curve Settings, Heating Curve Expert, And in here is a field called steepness of curve. And it starts at point 1, and you basically need to pick one. Now, the number is chosen normally by the boiler or heat pump installer, and I say heat pump because this is the same app that will be used for heat pumps. Heat pumps might have a lower steepness of curve, whereas boilers, combination boilers, will have a slightly higher steepness of curve. Our boiler installer originally said that my heat curve is 0.80. And I said, okay, but what does that mean? And he said, well, it's all determined by the sensor outside and what it returns back to sensoCOMFORT. So let's say, for example, the temperature is, and let me use this diagram over here. So I'm going to use 1.1 because that's the current curve that I'm on at the moment. So at 1.1, you can see I've drawn it. It's between 1 and 1.2. It's the red line. And let's say the temperature outside is -5. So what you do is you draw a line straight up to your heat curve line or steepness of curve, which is 1.1. And then you move to the left. And whatever that line is touching on there is the flow temperature. So that's what the boiler is targeting. If I have a 1.1 curve, it's targeting a flow temperature of around 54 degrees. Now, immediately you can see that that is a lot lower than 70 to 80 degrees. And that flow temperature will give me a desired temperature of 20 degrees, which is down over here. So let's say I go to my boiler thermostat, I should say, and I set the desired temperature to 19 or 20 degrees, and I can do that through the planner. So I go to the weekly planner, and you can see I've got a weekly planner of two different settings, one in the morning and one in the evening, and I'm wanting a 19-degree desired temperature. So the chart is obviously showing a desired temperature or a curve for a 20-degree, but so mine is slightly less, but it works in the same principle. I would just, whatever the temperature is at the time, so if I go and look at the temperature right now outside, it's 4.4 degrees, and I'm targeting a desired temperature of 19 degrees. The current temperature is 18.4. So we know it's somewhere below this curve, but it's 4 degrees, so it's around about there. If I go up to my curve, which is around about here, now, as I say, it's give or take because it's not exactly the same chart, but if I go to the left, the target flow temperature is going to be around 40 to say 43. It might be slightly less than 40, but because this is a chart for 20. So let me go and have a look at that now. So I click into this chart and it's telling me it's 42.5. So there we go. It's just in that region that I've just said. That's based on the temperature, 4 degrees, which I'd go up to the line and then go across, and there we go. And the way this boiler works is if the temperature starts to decrease, so let's say it goes to 0, then the flow temperature will increase because look, if I go up to the top of the line and move over to the left side, you can see the flow temperature has risen, so it'll probably be about 44 or 45 degrees. Now, if the temperature outside increases, so it's getting warmer, so let's say it's 10 degrees outside. Well, 10 degrees, you go up to the red line and then you go across, and now suddenly it's 37 degrees. So it's dynamic. Depending on the temperature outdoors, the temperature of the flow temperature increases or decreases. Now that's the advantage over a traditional combination boiler because those boilers are all running at 70 to 80 degrees regardless of the temperature outside. It only determines the temperature inside. So you can see you'd be using a lot more gas to heat the water for your radiators or underfloor heating, meaning you're going to be spending a lot more money on your energy. Whereas I'm only spending money on this line, basically, whatever the temperature is over a course of this line or curve is basically, it's going to determine the flow, and it's a lot less than a traditional boiler. And at the end of the day, that's the most important thing. So that's the heat curve. And as I say, it's set up, it can be either set up on the sensoCOMFORT. So what I can do is I can go to the sensoCOMFORT, click on the little hamburger menu twice, and then go to the settings, and then click on the tick, select installer level, check. The password is 00, just leave it as it is. Then go down to installation configuration, choose circuit 1, and then in here there will be a heat curve option. Here it is here. So this is currently set to 1.2. This is a simulation, so this is not my boiler, but basically that's where you'd select, you'd check it, and then you'd be able to adjust it by 0.5, or you can raise it by 0.5. So that's where you would set it. And then you'd go back to the menu. Or alternatively, you would go into the app, click on the cog, go to control, heating curve settings, heating curve expert, and you'd make the change here. Now, there's some other options that you can set, and that is the minimum flow temperature. Now, why would you set a minimum flow temperature? Well, the answer to that question is you don't want the flow temperature to drop too low, because if it goes down too low, it's going to have to take a little longer to get back up to the flow temperature that is the target flow temperature. So if you keep the flow temperature within the area that you're going to be heating, so you can see 25 to 39, 40, 41, 42, that's the area where I'm currently heating at the 4 degrees that it is outdoors, then it's not having to work too hard to get back to that point. The outdoor temperature switch off threshold, well, that's just when it starts warming up. So like in spring or closer to summertime, you want your boiler to turn off when it gets to temperatures of 18 degrees outside, because there's no point in running your boiler then. Previously, I spoke about load compensation. So in the sensoCOMFORT, in the menu, if I go back to settings and then installer level, and then installation configuration, circuit 1, there's a menu option in here called Room Temp Mod. Now this Room Temp Mod is used for load compensation. So ideally what you want to do is turn this on, set it to active. I need to use the menu. And basically that load compensation or room temp mod will control or monitor the indoor temperature. So of course, when the current temperature, I should say, in the room gets close to the desired temperature, it will start lowering the flow temperature so that it doesn't overshoot the mark. And it's better to do it like that, because you don't want to overheat your room and then it's too hot, and then you're likely to want to go to your thermostat and turn it down. This thing, it actually starts turning down the flow temperature before it reaches the desired temperature. And that's a really smart thing to do, because A, it's also reducing the energy consumption and it will reduce your bills. Once the heating curve is set and saved in your system, the best thing you can do is nothing, and just monitor if you are reaching the desired temperature every day. Now, it can be a little tricky if you're using this app and hoping to understand if you're reaching that heat curve or that flow temperature every day. I mean, at the end of the day, the goal is you need to reach this desired temperature, or whatever temperature that you've got set in your application or on the sensor comfort. So in my case, the target is 19 degrees. Now, you've got to bear in mind that a traditional boiler, because it's heating up over 70 to 80 degrees, that's a lot higher temperature than what we are getting on the smart boiler. And so these temperatures are going to be taking a lot longer to arrive in your boiler. And this all depends also on your daily or weekly planner. So are you getting that 19 degrees during the time frame that you have set? So like in my case, from 6:30 to 12, do I reach that 19 degrees every day? Now that's where it becomes tricky in this app, because there's nowhere that it really tells you if you're reaching that desired temperature. You either have to keep watching the app, which is not ideal, or you're going to be looking at this sensoCOMFORT display, and even this, it doesn't stay on all the time. So one way you can do it is by using Home Assistant. And Home Assistant is a tool that is used for smart homes to monitor or control or automate anything that has a sensor linked to it. Say, for example, a light switch or a blind or a motor or your TV or your energy bill or anything. And one of those things that you can monitor in Home Assistant is actually your myVaillant app. So this app has an API or an integration that you can add to Home Assistant. And then it has loads of advantages of doing that, because you can see I can plot out a number of days, and I can pull information from this application, things such as the current flow, the indoor temperature, the outdoor temperature, the desired temperature. So if we look at this app, the myVaillant app, this is the home screen, and on it you can see the current temperature and the desired temperature, and some little icon to show that the radiator or the boiler is on, and it's got a little bit of a flare going here. You can see the outdoor temperature, but you can't see the flow temperature or the current flow temperature. You don't see that information anywhere on this home screen. You've actually got to go and delve into a menu or two, and then you see the actual flow temperature of 42 degrees. Likewise, the water pressure. And the water pressure is actually a very important field on your boiler, because if your water pressure drops below 1, you need to go into the boiler and turn the tap on and fill it up. If it drops below 1, it's not good for the boiler. So not having that information on the front screen, or an alert or something telling you that you need to go and do that, can have a detrimental effect on your boiler at a later stage. Now, in our case, the boiler is in the loft. It's not easy to get to, and it would be nice if the boiler pressure did drop below 1, that it let me know. But funny enough, it doesn't seem to do that. And we've had an instance where the boiler was below 1, and the only way I was able to be notified was actually through Home Assistant, because I set up an automation. And in the automation, I said, if it drops below 1, I want you to alert me through my Google speaker. So Google spoke to me and said, hey, you need to go and fill your boiler. It's dropped below 1 bar. So that's where Home Assistant is very useful. It's also useful in that I can see all that key information that I've just been speaking about all on one screen. So you can see here, outdoor current flow, I can see that. I can't see it on this app. Indoor temperature, yes, that's the same. Desired temperature, humidity. I can also see the heat curve just there. It's right there, 1.1. I know that's the heat curve, and that's the heat curve that I've been on for the last week or two. And I can go in and I can actually go back in time and see for how long I've been on that heat curve, and like one day I did change it just briefly and then for a couple of seconds and then put it back to 1. But at least I can see that, where I can't see this information on the screen here. In fact, if I want to go to the heat curve, I need to click through 4 menus, which is slightly annoying. 1, 2, 3, 4. And now I can make the change to the heat curve. So again, that's where Home Assistant is very useful. I've got all this information on the screen, and there I've also got the water pressure, which I don't see on the front screen of this app. But now, in terms of the heat curve, I've been on the heat curve of 1.1 for at least 10 days, as you can see on this chart at the bottom here. And in that time, I can see on this chart the outdoor temperature, the desired temperature in green, the indoor temperature in yellow, and the current flow temperature. And this is where Home Assistant is very useful, in that I can see exactly what the boiler is doing. So you can see here, as the temperature outdoors has decreased, the flow temperature in the boiler has increased. Now, ultimately, what I'm trying to achieve with the heat curve is getting the current temperature to the desired temperature. So I can switch off a few things to see a clearer picture of what's going on. So let's just say I turn off the current flow. Now I can see the indoor temperature versus the desired temperature. And all I'm trying to see is, where does it peak or equal the desired temperature? So obviously these dips are when it's outside of the timer. So like here at this little point here, it's at 8:31. My timer is set from 6 or 4 o'clock. Let me just confirm. Timer, weekly planner, 16:30, 4:30 to 9 o'clock. So basically, where it dips like this is when it's outside of the timer. When it's peaking, the green is peaking, that's during the timer. And now I can see the desired temperature, which is the green, and the indoor temperature is below. So that's telling me that the heating curve that I'm currently on, in that short period of time, it's not meeting the demand. It's not reaching it. Um, and obviously when it gets cooler, like it does here, it's dropping the whole time. You can see it starts at 6 and it's going all the way down to 3. In that time, okay, it was outside, it was dropping because that was at night when we were asleep. So we don't really care about that. But it's in the morning when you really are interested in seeing what the indoor temperature is. And you can see it's below the green line. So this is telling me the heat curve that I've chosen is not the right heat curve. It probably needs to be higher, like a 1.2 or maybe a 1.3. And if I were to go and look at it, and click in heating curve. So for example, this is a peak time over here. And what have we got here? We've got 3 degrees, and I can see the indoor temperature is 18.6. Let me turn this current flow on. So at the time, it was, I said what, 3.6 or 18, it's 3.3. So what, you've got current flow of 43.5. So 3 is around about there. Yeah, look, yeah, it's in the 40s. So you can see the current flow is correct. It's according to this chart, but it actually needs to be more. It needs to be higher. If it was higher, I would be getting the indoor temperature breaching the desired temperature. So it just needs to be slightly higher, maybe 46, 47. But 46 and 47 is still a lot lower than 70 to 80 that a traditional boiler would be using. And that's, again, as I mentioned, the advantage of this type of setup. But you can see this um, as the temperatures are dropping, the flow temperatures are increasing. During the peak, it obviously goes higher because now it's on. There's demand for the boiler to be switched on and heating up to 40 to get that temperature to rise. But then out of the timer, it starts to drop, but you can see it keeps its level, so it's not dropping off and switching off completely. It's constantly looking at the indoor temperature and the outdoor temperature, and it's making adjustments as it goes along. And that's what's so great about this. So what you end up finding is that you maintain the indoor temperature. So you can see if you look at the desired temperature, the peaks, the indoor temperature stays constant. Now, one thing we've also noticed with this setup, and especially with these different heat curves, if you can maintain the heat like we are currently doing, I mean, it only really drops 1 degree from 18 maybe down to 17.9, but it's always in that region. We've actually found that this temperature is very comfortable. And before, when we had a traditional boiler, we were trying to get the boiler up to 21 or 22, and you'd always manually have to go and do it at the thermostat. And actually, that would be using a lot more energy than just having a consistent cooler temperature. I mean, we're talking 3 degrees less than what we were using in the past. So 3 degrees, that's actually a big savings. And you'll find once you're able to look at the data like this, you actually realize, you don't need to have the temperature at 21. This little spike here, where it was indoor 24, I pulled the thermostat from the hallway and I put it in the room where I was sitting. And obviously, with the door closed and the radiator was on, it went up very high. So that's what that little anomaly is. But yeah, this is the best way to actually monitor which heat curve you should be on. When you have all the information at your fingertips, then it's useful. Unfortunately, this app is not the best, and if you are to monitor your heating, you probably would have to do it in a spreadsheet or something like that, or just keep changing the heat curve until you find over a period of a couple of days you are reaching the desired temperature, whatever you've got set. But you need to also bear in mind that because the flow temperatures are a lot lower than a traditional boiler, the time it takes to reach that temperature will be longer. So that's another thing just to bear in mind. And that's where Home Assistant comes into its own as well. You can see how long, you can see the time frames, especially where the peaks are, how long it takes the heat. Let's see, if we start here, 17.9, and by the end of the 4-hour period, it's gone up 1 degree. So it'll take longer to reach that temperature. But the advantage of doing it like this is that you have a consistent heat. The other thing you'll notice as well is the radiators don't get hot, 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 where you can't touch it because it'll burn you. The radiator, when you touch it, doesn't feel like it's on, but it actually is, and it maintains that same heat throughout the night, the day, when any hour. You can go to the radiators and you can feel it, and you can feel that heat coming through, and it doesn't need to be super hot to be warm in your room. So that's another thing that we've noticed with this setup. The other thing we have done is opened all the TRVs. So all of the rooms except our bedroom are on 5, and that's because with this setup, the water flow or the flow temperature is obviously determined from outside, so you don't need to be adjusting them or closing them to allow more heat or less heat to come into the radiators, because it's already been done for you via the smart thermostat. So having those things open have saved us, just saved us time. We don't have to worry about going and messing around with the TRV. You just leave it. So yeah, that's how it's all set up. And um, yeah, if you have any questions, please leave them in the comments and I'll get back to you. If you want to know how I've set up Home Assistant to monitor my heating and especially the myVaillant app and pull the data, then again, leave a comment and I'll try and respond. Otherwise, thank you for watching and I'll see you in the next video.